Okay, everybody, let's AP Physics C. Let's quick take a look at the quiz solutions. Let's see. Overall, pretty good. I'm not actually going to do all the problems because actually one of the problems I had pretty much done in a previous video, the one of the hula hoop rolling down the hill, and going from there. So let's take a look at the other two really quick though. A couple of you made a couple mistakes on the one with the solid marble, and I'm guessing it's just a calculation error. I tried to put all the wrong answers in there. I apologize for that, but I went through and added all the partial credit. So really quick, a 2.2 kilogram solid marble rolls along the ground at a constant speed of 8 meters per second. Solid marble rolls along, its V is 8.0 meters per second. That's the center of mass velocity, right? Determine the total kinetic energy of marble. No, you don't need the radius of the marble. Moment of inertia for the marble is 2/5 mr squared. Sorry about the way I have to type that stuff in there. It's just the easiest way to do it. So that's the moment of inertia there. So the total kinetic energy is 1/2 mv squared plus 1/2 I omega squared, right? You got to have both components there. So let's go ahead and figure this out. So 1/2, the mass of it is 0.20 times 8 squared plus 1/2. We put that in here, so it's 2/5 times 0.2 times r squared. We don't know the radius, but I gave you a hint. Omega is v over r, so it's v squared over r squared, so it's 8 squared over r squared. The r's cancel, right? So the 2's cancel. You go through and do all of this, plug it in your calculator. You're going to get a total rotational kinetic energy. Well, let me just go ahead and calculate it for you quick so you can see what the two components are. 0.5 times 0.2 times 8 squared is 6.4, which was the wrong answer that a lot of you selected. So that's the center of mass motion, but you got to realize, think about this being a collection of molecules, right? Those molecules are moving forward together at 8 meters per second while they're all moving in a circle also. So let's add the circular motion component here now. So it ends up being 1/5, 1 divided by 5 times 0.2 times 8 squared is 2.6 joules, giving us a total of 9 joules of kinetic energy. All right, so get that one locked in, guys. That's a good basic question that you really got to get down, right? So it's the translational and the rotational component. The rotational component is coupled to the translational component by the fact that the angular velocity is equal to the tangential or linear velocity over the radius of the object. All right, so there's that one. Go back, pause it. The next one here that I'm going to do, everybody got it right. Number 2, solid disc mounted on a frictionless axle, rotates at an angular velocity of 6 radians per second. Who's that coming in? It's okay, you can come in. At 6 radians per second when it achieves a kinetic energy of 40 joules. What's that, beautiful?
I got you pizza.
Oh, you did? Oh, thank you. Got me pizza. Let me show everybody. I'm making a different kind of video today, Knowles. It's a quiz. I'm doing it on the whiteboard. Yeah, I'm going over quiz solutions. My daughter made me pizza. What's the green stuff on there?
That's green sauce.
Green sauce? Holy cow, that'd be kind of strange. But maybe it's like a pesto, huh?
Pesto sauce.
Pesto sauce. That'd be great. All right. Thank you. Thank you. Thank you. Beautiful. So solid disc, rotational axle, achieves a kinetic energy equals 1/2 I omega squared. Since it's on a solid axle rotating, it's not rolling. It doesn't say anything about that. It just gives me the rotational velocity, so there's not really two components here. You guys all figured that out anyways. I probably should have clarified that, but I guess I got lucky. You're looking for I, so it achieves a kinetic energy of 40 joules, 1/2 I, and then 6.0 rads per second, and you guys were able to solve for I, no problem. 2.2 kilograms. Number 3, hula hoop. mass M, radius R. One of you guys got it wrong. You fell for radical 2GH. You know, you've seen that before. It doesn't come out to be that. It comes out to be radical GH. Alright, just radical GH. Go watch the other video on rotational kinetic energy to see that solution. So that was a quiz. Overall, guys, a really great job on that. Hopefully you're not cheating. I have no idea. But anyhow, good luck to you. We'll see you later.